right, hi guys, and welcome to Lesson 4, Chapter 4, Section 2, Comparing and Ordering Rational Numbers. Before we get to that, I just want to review really quickly how we organize our numbers in the set of all real numbers, which is written with that fancy R. We have these different categories. So we talked about this at the beginning of Chapter 2. You don't even need to write this down if you don't want to. But the natural numbers, remember, those are accounting numbers. So if you're teaching a baby to count or a toddler to count, you'd start with 1, 2, 3, and so on. The next bigger group, the only difference between the two is we add in 0. The last chapter, we talked about integers, and if you watched about our mathematician on Friday, found out the guy that is responsible for giving us these negative numbers, Brahmagupta. And so we worked with those last chapter. This chapter we are talking about rational numbers. And the rational numbers are any number that can be written as a fraction, and that includes terminating and repeating decimals. Those are the decimals that can be written as fractions. Okay, and then the group that we're not even going to get to, you're probably not even going to get to until probably 9th grade, are our irrational numbers. And we talked about these before. Those are like pi or e or phi or anything that's not a perfect square root. So this is where we're, look at that. You've almost made it through all the groups of numbers. Well done. Okay, so comparing and ordering our rational numbers. My suggestion for this is if there's fractions involved, if all are fractions, yeah, I'll write that. That sounds good. If all are fractions, then you want to get a common denominator, okay, to be able to compare them. Okay, so if all you're doing is comparing fractions, then you want to get a common denominator so that they have the same bottom number. That's what the denominator is there. Okay, so for example, we want to put in, we're comparing two fractions, and these are actually mixed numbers. So we've got -1 and 5/6, and I want to compare that to -1 and 1/6. So we want to write whether it's greater than or less than or equal to. That's what we're looking for in between those two. And we have matching denominators, so that means we can compare these. Now, we're throwing in an interesting challenge with our negative numbers. If we think about these numbers on a number line, anything that's to the right is going to be greater. Anything that's to the left is going to be less than. So if we think about where these numbers are on the number line, if we put 0 here and we put 1 here, that's supposed to be a 1. And then this is -1 and -2. And then this is broken up into, those were mostly even. Okay, if we graph these two, -1 and 5/6 is going to be right there. Okay, -1 and 1/6 is right there. So I'm just going to put 5/6 and 1/6. Okay, so with our negative numbers, if these were positive, then we would definitely say that 5/6, 1 and 5/6 is bigger than 1 and 1/6. But when we have negative numbers, it's backwards from what you think it's going to be. And we have the proof right here. Whichever number is furthest to the right is the greater number. Okay, so the smaller the negative, the greater it is. I don't know. And remember, with your greater than less thans, you just want it to eat. You pretend like it's an alligator mouth, and you want it to eat the bigger one. Okay, but remember, with negative numbers, it's backwards. Sometimes I like to draw the teeth. Alrighty, let's try this again. We're going to do more negative numbers because I feel like that needs to be practiced more. Again, you're going to want to look for, you want to make sure that you have a common denominator. This example, has a common denominator. Again, we're just going to practice on the number line. So -5 and 5/9, and we're comparing that to -5 and 2/9. Okay, so if these were positive numbers, it's pretty easy to see that this one would be the bigger one. But because they're negative, that means this is the bigger negative, or the lesser, to the lefter of the two numbers. Okay, so this one again, we're going to eat this one with negative numbers. Remember, it's backwards. So whichever one looks smaller is actually bigger. Oh, trying to explain this, I hope you're getting it, because it can get confusing. Let's try ones with not a common denominator, so I can remind you how to do that. But this time we won't worry about negatives. How does that sound? Deal? Okay, so we've got 5/6, and we want to compare that to 7/9. Okay, so we want to figure out what a nice common denominator would be between these two numbers. Okay, now you can always just multiply them together, but 54 seems a little bit extreme, especially because I know both of these numbers can go into the number 18 pretty easily. So to get to 18 and 18, we have to multiply 6 by 3. And whatever we do to the bottom, we have to do to the top. So the top becomes 5 times 3, which is 15. On this fraction, to get 19 to be 9 to be 18, we're going to multiply by 2, and whatever we do to the top, or to the bottom, we have to do to the top. 7 times 2 is 14. Now that we have a common denominator, it's very easy. All we have to do is compare the numerators. Okay, and in this case, we don't have any negatives, so the bigger one is just the bigger one, and there you go. Alrighty. Let's try this again to practice getting a common denominator. This time we will have a negative 3/5. We're going to compare that to negative 2/3. Okay? In this case, because those are both tiny prime numbers, we are going to get a common denominator, we will just multiply them together. So this one where I'm going to multiply by 3 and 3, which becomes negative 9/15. And this one we're going to multiply by 5 and 5, which becomes negative 10/15. Okay? So in the regular world, if these weren't negative, the 10/15 would be bigger, right? But because these are negative, the 10/15 is more negative, so that means it is less than the negative 9/15. Okay, I'm hoping you're starting to get a feel for what's happening there with the negative numbers. Okay, some other problems you're going to see is that they're going to want you to write numbers in order from least to greatest, and usually they go least to greatest. So we want to write in order from least to greatest. And the numbers we're going to use are 3.44, pi, 3.14, and 3.4 repeated. Those are all really close numbers, right? My recommendation for comparing numbers is to just change everybody to decimals. Okay, in this case, we have decimals already. Sometimes they like to throw fractions in here. Change everybody to decimals. We talked last lesson about changing fractions to decimals. Remember, just do the division. And then I like to write them in order, lining up the decimal point, so it's easier to compare places. So I'm going to write them down the side. Pi, usually we use 3.14159. I think that's going to be sufficient. I don't think we have any more decimal places. I'm going to add in some zeros just so they all go to the same place. This one is just 3.14, which means we'll have zeros after it to fill it in. And then this last one, 3.44444. Okay, I feel good about that. Just had to add a couple zeros and knowing pi. You won't have to deal with pi. And that's all I know of pi. There's a lot of people that know a lot more of that number than I do. Okay, now we're going to compare place numbers. So first I'm going to look at the tenths. Well, our whole numbers, they're all the same, so that doesn't help us at all. Okay, so looking at the next one, we want the least. So the ones with the 4s, those aren't the least. The ones with the 1s there, that's what we're talking about for the smallest, okay? So those are the same, and then we're going to look at this column, and those are the same. And then we're going to look to this column, and finally we have a different number. So the smallest one is going to be the 3.14. That's just plain 3.14. Okay, and then really close to that is our pi. Now sometimes it's tempting to just write out the decimal form, but when you're putting your answer back in, they want the answer to be in the original form. So I'm going to put 3.14 and then pi. Okay, so we got those two. Now we're going to look at the ones with 4s in the tenths place, and then they have 4s in the hundredths place. And here's our first difference. Okay, so 0 is less than 4, so our plain 3.44 is slightly smaller than 3.4 repeating. Okay, and there you go. That's them written in order. Now, sometimes the book, assuming that you're teaching the book in order, which I don't, thinks that we've already reviewed percents, and I know that you've learned about them last year, but let's just practice. I'm just going to turn my paper over so I have more space. Let's just practice how to change a percent to a decimal. Okay, and again, I'm hoping you guys remember from last year, but in case you don't, you move the decimal place over 2 places to the left. Okay, so we're making smaller numbers. We're going to make the percent is bigger than the decimal form. Okay, so for example, if we have 45%, right now, it doesn't look like there even is a decimal place. When you can't see a decimal, it means it's at the end of the number, right? Okay, and my rule is I'm going to move the decimal place over 2 places to the left. So I just like to do the little jumps, 1, 2, and there we go. Now, 45% is the same thing as 0.45. And again, remember, it's really good to have that 0 on the other side of the decimal. Okay, here's another one just to practice. It's 74.5%. Okay, and this time we can see our decimal place, so that's cool. And to change it to a decimal, we move that over 2 places, and it becomes 0.745. Okay, and then once you get it to the decimal form, that's going to make it easier to compare your numbers. All right, so let's do one more example then of least to greatest. All right, and we're going to compare 23% and 0.21 and 1/4 and 1/5. So right now we only have one number that's even a decimal. We have to change all the other ones. Okay, so here we go. I'm going to change them and I'm going to write them vertically so we can compare place to place. 23%, remember we move the decimal place over 2 places to the left. And so 23% is the same thing as 0.23. This one is 0.21. And then we should know what 1/4 is, right? We talked about that. Remember that's a quarter, so 0.25. And then 1/5, that's another one that's nice to know. Or you can think about the 5s and the 20s again, but it comes out to be 0.2, and I'm going to put 0.20 just so that we have a number to compare there. All right, So let's compare. Our ones place, they're all the same. Our tenths place, they're all the same. So we're looking in the hundredths place, and now we're just going least to greatest. So the smallest is the 0.20, which is 1/5. And remember, they like to have it back in their original form. So 1/5 is the smallest. And then next after that, we're going to do the 0.21. And then next after that is the 0.23, which is our 23%. And the last and the greatest, funny how that works out, is the 1/4. Okay? And that's about it for comparing rational numbers.